anyway, whenever we're working these problems for this test, there is pretty much a format, a checklist that my brain goes through. Number one, is it in order? And this step isn't that important because most of the time they are in order. If they aren't in order, it's sort of an obvious thing. Like, is the thing set equal to 0? If not, set equal to 0. If you spend more than I don't know, 2 seconds thinking, is this in order? Just skip that step and go to the next step. GCF, we have to look and see if every single thing, always, we have to check to see if it has a GCF. From there, we want to say, do we have a binomial, trinomial, or a polynomial? Because if we have a binomial, there are 3 formulas: difference of squares, and that's if you have a squared minus b squared. It can factor into a plus b and a minus b. With these 3 formulas, it's really just as important to know the name of the formula as it is to know the formula, because the name of the formula really identifies what formula to use. There's also another difference formula. It's difference of cubes. And that's if you have an a cubed minus a b cubed, okay? The minus is what makes these formulas difference, okay? So if you have an a cubed minus a b cubed, you had to find out what a and b are and subtract them. And then you'll say a squared plus a times b plus b squared. And there's just one more formula, and it's a sum of cubes. This is our only sum formula, and it's one of 2 cube formulas. It's if you have an a cubed plus a b cubed. So what makes this a sum is the plus sign. And so you'll find out what a and b are, and then you'll say a squared, ab, b squared, just like the difference of cubes. But our signs are minus plus. Okay? So we must memorize these 3 for the test. We're going to use all 3 of them on the test. If it's trinomial, meaning there's 3 things, trinomial, we use that rooftop method where we're saying, what do you multiply to get, and what do you add to get, yada yada, okay? And then if it's a polynomial, meaning there are 4 or more terms, then you factor by grouping. And so binomial, 2 terms, trinomial, 3 terms, polynomial, 4 or more, but we're only going to have 4-term polynomials. And then once you identify what type of function you're dealing with and use the correct method and factor it, if the directions say, if they say factor, you're done. If they say solve, set each factor equal to 0 and solve for x. You can use this template or these steps for every single problem, every single one of them. So the first problem that we are looking at, (5x squared plus 26x plus 24. Is it in order? It might as well be, okay? Like, I don't see anything that's, like, sticking out like a sore thumb. Is there a GCF, 5, 26, 24? No. There's not an X in everything, so no. Binomial, trinomial, or polynomial?
Trinomial.
Trinomial. So it's that rooftop method where you're saying, what do you multiply to get that 5 times 24 figure? So let's see. What do you multiply to get 120? It's positive. And add to get that middle number of positive 26. Well, since that 120 is positive, they're the same sign, whatever two numbers you choose. They have to be the same sign if you're multiplying to get a positive. Since you're adding them to get a positive, they'll both be positive. Okay, so the two numbers that I choose have to meet both conditions. Okay, so 120, let's see, 120, 2, 60, 340. What a dummy. Yeah, no, that's it. 340, 430, 524, 6, and 20. That's it. Okay. So now the way that people have probably been showing you to work these trinomials, I'm going to do it a little bit different. So I want you to start doing your trinomials like this. We're going to turn, so the three types of functions, binomial, trinomial, and polynomial. Polynomials you've always factored by grouping. Once I do this step with my trinomials, I turn it into a 4-term polynomial, so I can factor by grouping, and I do it by this. 5x squared stays the same. The 24 on the end stays the same, but in the middle, instead of writing 26x, I write 6x and 20x, or 20x and 6x. It doesn't matter the order in which you write it. But this is the same thing. 6 and 20 is 26. And, if I combine the like terms, these two functions are exactly the same. Now that it's a 4-term polynomial, I can factor by grouping.
Okay.
So, on this side, there's a GCF of x. And if you pull that x out, you're left with 5x plus 6. You see what I'm talking about?
Mm-hmm.
Here, 20x and 4, there's a GCF of 4. Yeah, just 4. And you're left with 20x divided by 4 is 5x. 24 divided by 4 is 6. Those are the same, right? Pull it out, and you're left with x plus 4. The directions for this one said factor, so you're done.
What?
So you're left with x plus 4 because if you take the 5x plus 6 away from them, because they have it in common. So if you take that GCF, 5x plus 6 is technically a GCF because both sides have that in common. If you take it out, if you take it away, you're left with x and you're left with 4. So, first of all, one of our steps, like step 3, is to determine binomial, trinomial, polynomial. This is a trinomial, okay? But let's make sure it's in order. It's in order, okay? GCF, no GCF, trinomial, rooftop. So we're seeing what we multiply, and I always write these statements out. We're seeing what we multiply to get -10 and what we add to get -9. If you're multiplying to get a negative, your signs are different. And since you're adding these two different signs together to get a negative number, your larger number will be negative. And these plus minus circle things, I'll write those every single time. So -10, let's just think about the numbers really quickly. 1 and 10, 2 and 5, and that's pretty much all the factors of 10, and we're going to make the larger ones negative. So 10, yeah, -10 and +1. So I can write this as 5x squared plus 1x minus 10x minus 2, because again that adds to give me -9 in the middle. Or I can write it as 5x squared minus 10x plus 1x minus 2, okay? It doesn't really matter the order in which I write that.
For a second.
I multiply 5 and negative 2 together to get negative 10.
Yeah.
That's one of my conditions for the two numbers that I choose, okay? And then they also had to add to give me negative 9. So once you choose these two numbers, I'm rewriting this whole problem. I'm rewriting 5x squared minus 9x minus 2 so that it's 4 terms, so I can factor it by grouping. And I'll rewrite the middle. That's the part that I rewrite. I rewrite the negative 9. So the 2 stays there, okay? And this is the part that changed, okay? Anyway, so now I can factor by grouping since it's 4 terms. On this left side, 5x squared and 10x have a 5 and an x in common. And you're left with x minus 2. And over here, okay, always take your sign with you, okay? X minus 2 doesn't have anything in common. So we'll just say it has a 1, right? And you're still left with x minus 2. And look how convenient. X minus 2, right? They have that in common. Pull it out. And if you pull it out, you're left with 5x and positive 1. And the direction said factor completely, so we're done. So we're still going to use those 6 steps from, I say 6 steps, I think it was 4 steps actually, that I wrote on the first slide. So making sure that we are in order. It's, I'm looking at it, spend about a second on this. It's in order. GCF, does it have a GCF? 3, 27, 60. I can pull out a 3, and they all have a Z. I can pull out a Z. So what I'm left with is x squared. 27 divided by 3 is 9x, and 60 divided by 3 is 20. And okay, so now step 2 done. Now I need to determine, do I have a binomial, trinomial, or polynomial? And what you're asking that about is what's left. If you pulled out the GCF, you're asking about what is left, and that's a trinomial. Okay, this trinomial rooftop method, multiply to get 20, add to get 9, positive 9. Since we're multiplying to get 20, meaning this was just 1 right here, the last problems where I rewrote the problem and turned it into a grouping problem, I don't have to do that with this one. I can, and it will work. I don't have to do that with this one, only because this A term right here is 1. Okay, so no need to do that. Anyway, let's think about this really.
5 and 4.
5 and 4. So I could do this, and I could find GCF and factor by grouping. But again, since this was 1 right here, all I have to say is x plus 5, x plus 4. Okay, so I would save myself the burden. Given step 1, and honestly, it probably isn't. I gave you the steps in the beginning to make it a system, to make it the same every time. So don't let that throw you off, because that's, more steps. That's a template, and that works, okay? So step 1, are you in order? No.
These would be 4z squared, 39z minus 40.
Okay, step 2, GCF, please be a GCF. Please be a GCF. No, there's not. Binomial, trinomial, polynomial, trinomial. So rooftop, we're multiplying to get, and it hurts your feelings, but it's not bad. Negative Well, I'm talking about how big this number is.
Yeah, fine.
Okay, and wait. It's not 160, it's 1600. I knew something was off. And we're adding to get positive 39. Since we're multiplying to get a negative 1600, our signs are different. Since we're adding to get a positive 39, our larger number will be positive, meaning the smaller one's negative. Now, we can go through that whole list of 1 and 1600 and 2 and 800, okay? But when the number is that big, I do like to play around a little bit with the numbers, and then if I can't find it, I'll go back to that list. So, like 1600, let's try
There's 2 and 8.
20, 2 and 8.
No, not 2 and 8, but
2 and 80?
2 and 80, yeah.
2 and 80 don't add to give me 39.
That's right, though. Yeah.
1600 divided by... Okay, so it is 25 and 64. That's actually a pretty hard one to guess on. You may just would have to go through that list all the way, till you find it. Anyway, the larger number we said was positive, the smaller would be negative. And this is one where it is necessary to rewrite 40z squared plus 39z minus 40 as a polynomial so that I can group it, because this was 40 and not just 1. Okay, so I'll just say minus 25z plus 64z. And now I can group. This is the one extra step. This is the one extra step. But it's a step that we already have experience with too. Okay, so 40 and 25. I think they have a 5. And maybe is just a z. And I would be left with 8z minus 5. Okay? Okay, next side, bring the plus down. Maybe just a 8. And be left with 8z, and negative 40 divided by 8 is a negative 5. So they have in common an 8z minus 5. Write that down.
8z minus 5, close parentheses, is then 5z plus 8.
Perfect. And the direction said factor completely, so you are done. If it said solve, you would set those factors equal to 0 and solve for z, but factor completely, so we're done. Factor trinomial. Step 1, is it in order? Powers are in order. Might as well be. Step 2, GCF. There is not a number in common, but I can take out a y squared and be left with 5y squared minus 13y minus 6, okay?
Pause and let me show you how I've been working this for a second.
Trinomial, polynomial, trinomial. So we have to say you're multiplying to get, and the reason we say this and are doing these two stipulations and finding factors that fit the multiply and add, but because we're going to rewrite the middle. So we're looking for two numbers to rewrite the middle. Okay, so they had to multiply to give us negative 30. And these two numbers had to add to give us negative 13. So if they're multiplying to give us a negative, they're both different signs. And if they're adding to give us a negative, the larger number is negative. Okay, 30, 1 and 30, 2 and 15. Would 2 and 15 work? The larger number negative, smaller number positive. That works. So y squared, just kind of let it hang out. We're going to put it in front of our final answer. But all I'm worried about factoring right now is the 5y squared minus 13y minus 6. That's what was left. So I'm going to rewrite the trinomial into a 4-term. And I can just say 2x and 15x minus 15x. Or I could have said 5y squared minus 15x plus 2x. That order doesn't matter. Now we just need to group. I pull out, oh, sorry. I forgot what my variable was. Okay, there we go. Need to group. I pull out what's in common. Anyway, we have a y in common in that first binomial, and you would be left with 5y plus 2. And here, always take out this sign that's in front of the first number. And they have a 3 in common. And you would be left with negative 15 divided by negative 3 is positive 5. Negative 6 divided by negative 3 is positive 2. And look, that's the same thing. If you take it out, you would be left with y minus 3. And don't forget that GCF that we took out at the very beginning.
Let's pause again.
So that list of steps that we have from the very beginning says, okay, is it in order for step 1? And it might as well be. Step 2, is there a GCF? Don't think so. Step 3, binomial, trinomial, or polynomial. Well, here's the thing. A lot of these questions will tell you whether or not it's bi, tri, or polynomial. And with a binomial, we have only 3 options. We have a difference of squares, a difference of cubes, and a sum of cubes. That's the only 3 options we have. If it doesn't fit one of those formulas, it is it's going to be prime if it doesn't fit one, because it wouldn't there wouldn't be anything to use. So, are we dealing with a difference or a sum?
Difference.
Difference. So rule out the sum of cubes. Is this a cube or a square?
Square.
It's a square, so difference of squares. And that formula goes, if you have a squared minus a b squared, which we do, we have 2 perfect squares that are subtracted from each other. Take the square root of both of them to find out what a and b would be. And just add and subtract them. So you're saying 5, what's the square root of x squared?
Is
X.
5x, yeah.
And then the square root of 121 is 11. And so you are done with that. Is it in order? Yeah, might as well be. GCF, nope. Binomial, trinomial, polynomial. Binomial. 3 formulas. Difference of squares, difference of cubes, sum of cubes. Okay. Is this a difference or a sum problem? Sum. So that rules this out. Is this cubes or squares?
Squares.
Squares. Well, that rules the cubes out. What's my options? Do I have any options? No.
So why is it not a difference of sums, though, just to be clear?
Why isn't it a sum of squares?
Or just a difference in sums?
It's not a difference because it's a plus sign.
Okay. Okay, that's right.
And it's not a sum of squares. Now, it is a sum of 2 squares.
That's what I meant.
But there's not a formula for that. No formula. It doesn't exist. Okay, so it's prime, meaning you just can't factor it. Another example of sum of
just
squares?
like a way it would look, sum of squares. One more look.
25y squared plus, it's going to have a plus, 16. It's a binomial. It's only three formulas, okay? You have 2 difference formulas and 1 sum formula. The 1 sum formula is for cubes, and these aren't cubes.
So my question would be, what would be the difference in something like this and this, which also has a variable in a square?
Nothing, because they're both prime.
Okay, they're both prime. Okay.
Now, if it were this, then it would be a difference of squares.
Mm-hmm.
And we have a formula for that.
Okay.
But we don't have a formula for this. So, just because I'm OCD, we're going to go through our steps. Is it in order? Might as well be. GCF? No. Bi-tri-poly, yeah, well, it's a binomial. And it's with a binomial, there's three formulas: difference of squares, difference of cubes, sum of cubes, and it tells me to go ahead and use the sum of cubes, so that's great. I mean, I don't even have to think there. I'm gonna think about why, just so that we can have a knowledge for other problems. Oh, wait, sum of cubes. Okay, sorry. So it's a sum problem. So it just rules out the two difference problems, and they are cubes, so that does fit the sum of two cubes. And that formula goes: if you have an a cubed plus a b cubed, you need to find out what a and b are by taking the cubed root of both of those, add them together, and then use a and b to figure out the trinomial behind it. A squared
Times
minus
AB
AB plus B squared. Okay, so our a cubed in this problem is y cubed. So the cubed root of y cubed is just y. Y times y times y is y cubed. Okay, so that's why the cubed root of y cubed is y. The cubed root of 64, our calculator tells us this.
Is 4.
It is 4.
I've done this problem a lot.
So we know that part of the binomial already. Now we're going to use this a that we found and this b to find out what a squared and ab and b squared are. A squared, well, y is a.
Mm-hmm.
So a squared is just y squared.
Y squared.
A times b, well, that would be 4 times y.
Yeah.
And b squared, so that's 4 squared, which is 16. And you're done.
Yeah.
Okay, so our list of steps. Step 1 is in order, might as well be. Okay, I don't spend a lot of time on that step. Step 2, GCF. 2. You're not used to having a GCF in these binomials, but there is a GCF of 2 at least, because they're both even, so we'd be left with 64x cubed and 125y cubed. And okay, so bi-tri-polynomial, this is a binomial and it's a difference of 2 cubes. The reason being because there's a minus sign and they are cubes. Okay, that formula goes, let me tell you the sum formula real quickly so that we can compare the two. So on the top, I got a sum of 2 cubes. On the bottom, I got a difference. You will find a and b for both of them. In the sum, you add them. In the difference, you subtract them. In both of them, you will have a trinomial that follows with an a squared, an ab, and a b squared. For the sum of cubes formula at the top, it's plus, minus, plus. For the difference of 2 cubes at the bottom, it's minus, plus, plus. So your for both of them, your a, your b, your a squared, your ab, your b squared is all in the same place. It's just these signs that change. And again, for the sum, it goes in the order of plus, minus, plus, and for the difference, it goes in the order of minus, plus, plus. Okay? Anyway, that being said, let's determine what this is a difference of cubes. The cubed root of 60...
So we went from 28 to 64, why?
Because 2 was a GCF. I took a 2 out. 128 and 250 were both even numbers.
Yeah.
So 2 was a greatest common factor.
All right, explain it differently. That didn't work.
Every single time you have to look and see if you have a greatest common factor. With binomials, with any of them. We're not used to having them in trinomials, but they can happen. like, I mean in binomials, but they can happen. Like if I were working this problem, x squared z plus 3xz plus 2z. If I were working this trinomial, I would have to first factor out the GCF of z, right? And be left with x squared plus 3x plus 2, and the factors of 2 that add to give you 3 are x plus 1 and x plus 2, yada yada, okay? Anyway, but here I had to take out my z first.
Yeah.
Okay, well here you gotta take out a 2 first. They have a 2 in common. If you do not take out the GCF first, if there is one, and you do not take it out first, it will not factor correctly. It won't. Okay, one reason being because if I would have left this as 128 and negative 250, 128 isn't a perfect cube. There's not a cubed root of 128. There's not a cubed root of 250. But thankfully there was a GCF, and there is a cubed root of 64, and there is a cubed root of 125. So that's, and look, I'm going to set myself up for success. I'm using the a minus b formula and the a squared plus ab plus b squared. So I'm just going to go ahead and put my minus plus plus there. Okay? Cubed root of 64, 4. Cubed root of x cubed, x. Okay? So the cubed root of the variable cubed is always just the variable. Cubed root of 125. Cubed root of y cubed. And I mean, there is a 2 out front. You can put it there at the very end, or you can just put it there now, but that was the GCF originally. Anyway, are you with me? Okay, so if a is 4x and we need to write a squared, then that is 16x squared. If a is 4x and b is 5y and we need ab, then that's 20xy. If b squared is 5y, if b is 5y, then b squared is 25y squared. Did the formula. Done. So if you'll notice with every single one of these problems so far, I've asked myself those steps. Step 1 is in order. If I can't figure that out in a second or two, then just keep going. Step 2, is there GCF? And most of the time there isn't. But there is one.
With the x, yeah.
Now, out of what's left, do we have a bi, tri, or polynomial?
Bi.
We have a binomial. We have 3 formulas for that. A difference of squares, difference of cubes, and a sum of cubes. Is this a difference or a sum?
It's difference, yeah.
Difference of squares, right? Because these aren't cubes. So that formula goes that a squared minus b squared equals a plus b, a minus b. So set myself up for success, just write my signs down. Gotta take the square root of 25 and y squared.
Makes it 5y.
And the square root of 9.
A 3.
This question is the easiest question on the entire test, but it's very confusing to a lot of people.
I still got it wrong yesterday somehow.
The reason we factor is so that we can solve things. Things are easier to solve when they are completely factored. And on all the questions before number 12, we factored things. We factored trinomials and we factored binomials. And when we get something like this times this, and this times this, yada yada, right? Well, I already have that, okay? Now, this is the first one I believe that we've done that said solve instead of factor. If it said factor, there would be nothing I could do because this problem is fully factored. To factor means to multiply, and this says x plus 4 times x plus 10. This thing is fully factored. So when something is fully factored and it's asking you to solve, there's just one step further to do, and that's to say, set each factor equal to 0 and solve for the variable. So if I'm solving for x, I need to move 4. And then I'm left with negative 4, right? And if I'm solving for x, I need to move 10, and I'm left with negative 10, right? So in the little box, -4, comma, -10. Done. Okay, so solve the equation. Every single problem, we've went through those steps. Is in order, it might as well be. GCF, no. Bi, tri, poly, try. Factor using, your trinomial method. And then that step 4, we really haven't paid much attention to. It is it asking to factor or is it asking to solve?
Yeah.
It's asking to solve.
Mm.
So there's, again, that one more step with these that say solve. So if it were asking to factor, this is a trinomial. You're multiplying to get positive 32. You're adding to get -12. Since you're multiplying to get that positive, they're the same sign, either both positive or both negative. But since they're adding to get a -12, they need to both be negative. And now, I've shown you that new way with these trinomials of turning them into a 4-term polynomial and then grouping. But do remember, you don't have to turn it into a 4-term polynomial and group whenever this a term is 1. All you have to do is, okay, well, let's choose our two numbers really quickly.
-8, -4.
-8, and that's it. So instead of having to do this and group, which you still can do and we'll come up with the right answer, all you have to do is this. There's your two factors. But we're not done.
You say +4.
So yes, the answer will be 4 and 8. But it's because you move everything over and solve for x. So 4, 8. That's not a coordinate, by the way. Yeah. That's 4 and the other one's 8.
Yeah.
Coordinates have parentheses.
These have come a lot easier to me doing these.
Okay, so our steps again, and they're getting annoying at this point. I mean, I'm annoyed because I'm going to say I'm erasing, but they are. Okay, is it in order?
Yeah.
No, because if we're solving it, but no, we're not in order because the ones that have solve as the directions have equal signs in them. The ones that say factor don't, because you're not solving like getting x equals or whatever. Anyway, if we're going to solve that equation and we're going to factor it, it has to be set equal to 0. So is it in order? No. Move the 32 over, and now it's in order.
Yeah.
No GCF. This is a trinomial. We're multiplying to get -32. We're adding to get -4. If you multiply to get a negative, your signs are different. Whoa, John. And if you're adding to get that negative from these two different signs, your larger number is negative.
It's 8 and 4 again.
8 and 4, and we don't have to group because of this 1 right here. So x minus 8, x plus 4 equals 0. So when you do, and my advice to you is, on these solve ones, you're probably thinking, okay, I gotta find my signs, and then I'm going to do the opposite sign. Give yourself, respect this problem enough to write this step out correctly, and then write this step out correctly, because there's less of a chance, even though it takes more time, there's less of a chance that you will make a simple error at the end. And because what some people do is they change their signs and they change them again and change them again because they're doing it in their head. So make sure to write it down on paper, okay? So with this one, are we in order? Nope.
Yeah, it's 14 over.
Okay, bi, tri, poly. Well, wait. Is there a GCF? And whoa, Johnny, there actually is a GCF. I was about to not pull it out. There's a GCF of 2. Let's see. 20. I'm losing my mind.
7.
Okay, There we go. Okay, now trinomial, so you're multiplying to get negative 21. You're adding to get positive 20.
Hang on just a second. Okay.
This is rooftop, so 3 times negative 7,
Okay,
so I
that's
got
right, see
negative
that.
21.
Yeah, I see that. Which is just
So
1.
since there's not a 1 right there, since it's a 3, that means I'm going to have to end up rewriting that so that I can group it.
Yeah.
Anyway, since you're multiplying to get a negative, they're 2 different signs. Since you're adding to get a positive, you're larger
21,
than
negative 1.
positive 21, negative 1. So 3x squared plus 21x minus 1x minus 7. The 2 will come down. Let's not put it there yet. I don't want it to confuse us. Let's group and pull out a GCF in the front. There's a GCF of 3x. I'll be left with x plus 7. Okay, now the thing I can't forget to do is whatever this sign is, pull it out. Okay, so if it's a negative, pull out a negative. There's nothing other than that negative that they have in common. So we can just say negative 1. So we would be left with x plus 7. That's the same thing. It should be. So if you take it out, you're left with 3x minus 1. And we've done some great work on this problem. It's factored completely. But we're not done because it said to solve. So I get 3x equals 1. So we get 3x equals 1, and then we divide by 3 to get x by itself. So 1/3. And then this one is more simple, right? Okay. And then you're like, whoa, what's that? I'm uncomfortable. That's a number 2, and that's a number 0, and they are not equal to each other. That's a lie, so don't use it.
That's one I'll go back on and look at again. This one I've hated a lot going over.
Okay, so same steps. Don't get ahead of yourself on this one. Is it in order? Sure. GCF, don't get ahead of yourself. Yes. GCF of x. Okay. Bi, tri, or poly. It's a binomial. And there's a difference of squares formula, a difference of cubes, and a sum of cubes. This is sum or a difference?
This is difference.
This is a difference. Is this cubes or squares?
Squares.
Squares. So that goes plus, minus. We're going to go ahead and put our x out front, our GCF of x. And let's see if there's a square root of these things. Square root of 36x squared is 6x. Square root of 1 is 1. Now, we are factored completely. Let's set every factor
to 0.
Now, I will go ahead and say this. X equals 0. On the last problem, we had something that said a GCF of just 2. And that's the number 2 equals 0, and that's not true. If it has a variable in it, though, if it were like 2x equals 0, I could solve for x divided by 2, and x would equal 0. Here, it's a variable equal to 0, and so that is true. That can be true, okay? And since it started out as a cubic, when you solve a cubic, there's 3 answers. When you solve a squared problem, where the highest power is squared, there's 2 answers. Anyway, so that's a little hint there. Let's solve for x on these. It's not bad. We're going to move the 1 over first. Get negative 1 equals 6x, and then divide by 6 to get x equals negative 1/6. And move 1 over. Divide by 6. X equals positive 1/6. So, in our x equals box, 0, negative 1/6, and positive 1/6. Make sure to put it in this order. If you want to drive yourself crazy, because the order doesn't matter. I'm just kidding. Okay, you could write negative 1/6 and 0 in positive order. I mean, I'm just trying to mess with your head. I shouldn't have done that. So, same steps. Do you know the steps? What's the first step?
To see if they have any
Is it
it's
in-
like in I call it ascending order. That's not
Basically, yeah, okay. So, yeah, sure, it is. GCF? Whoa. Yeah,
Nice.
yeah, there is. I wasn't expecting that.
Mhm.
3 formulas for a binomial: difference of squares, difference of cubes,
Difference of
sum
sums.
of cubes. It is a sum. This is not a difference formula,
Mhm.
but this is not a sum of cubes. There's no cubes.
Yeah.
So
It's not none.
it's actually already factored
Mhm.
out completely. So all I had to do is say x equals 0 and x plus 22 equals 0. So x equals negative 22 and x still equals 0.
0.22. Yeah.
So simple that it's hard to do. It'll throw you off. Step 1 is in order. It's not in order for 2 reasons. The
right hand side of the equal sign. Obviously.
yes, but don't just change it to this, because then it's still not in order.
X.
Make sure that x is in the middle.
Mhm.
And then you're saying, okay, GCF, no. Try by poly, try.
So we do the.
So multiplying to get negative 14, adding to get 5, positive 5. If you're multiplying to get a negative, signs are different. If you're adding to get a positive, larger numbers, positive.
It's 7 and 2.
7 and 2, you're faster than I am. I don't have to group this one because of the 1 right there. So I can just say x plus 7, x minus 2 equals 0. And so now x equals negative 7 and 2.
How many of these are on the test?
This one might be my favorite problem and the one that I hate the most at the same time. So we worked one really similar to this. I think it was like number 11 or something. But it was set equal to 0. And when it was set equal to 0, I just was able to say x minus 3 equals 0 and x minus 5 equals x plus 5 equals 0 and, solve for x. This one is not that simple. See, okay, so when you're factoring those when you have a function, you can solve that by setting the factors equal to 0.
Yeah.
You don't solve it by setting the factors equal to a different number than 0. You solve it by setting it equal to 0. So this doesn't work to say x minus 3 equals 9 and x plus 5 equals 9. Because the rule is, you can't get stuck on wondering why it doesn't work, because we won't figure that out. We just have to know that you can only set it equal to 0. So since it's not, I need to move the 9 over, but this doesn't look pretty. So before I move the 9 over, I think I'm just going to FOIL this out to get x squared plus 5x minus 3x minus 15, which is x squared plus 2x minus 15 equals 9 minus 9 x squared plus 2x minus 24 equals 0. So now, is it in order?
Yeah.
Finally, that was just step 1. Just step 1. Is it in order? Now it is. Okay, step 2. Is there GCF? Nope. Step 3, by try poly. It's a try. So you're multiplying to get 1 times negative 24, so negative 24. You're adding to get 2, positive 2. Signs are different because it's a multiplying to get a negative. Adding to get a positive, though, so your larger number will be positive, and it's 6 and negative 4, right? But I don't need to group these. I could, but I don't need to because of this one right here. So x plus 6, x minus 4 equals 0, so x equals negative 6 and positive 4 for the win.